Guys, welcome back. Today we're going to look at 3 more composite figure problems. They are a little bit harder than the ones that we saw yesterday, so let's take a look at them. The first one is from the textbook. We have a bunch of 30 by 30 square tiles to be filled up in this area over here. Okay, so they're asking how many of those you can fit it in. Now the first thing that we definitely want to do is to figure out how much space do we actually have in this region over here. So let's find out the area. Okay, what I'm going to do is, again, it's really up to you, but I'm going to separate it like this. So I'm going to calculate this part plus this part, okay? By the way, I think it's probably a better idea that we can make the unit the same. We have 30 centimeter for square tiles, so let's convert all these to centimeters as well. So we got 600 centimeters here, and then this is 240 centimeters. This is 60 centimeters, okay? We're good. So that the bottom big rectangle, we got 600 times 240 plus the top part, we have 60 centimeters multiplied by this guy over here, and this is the same as this, and then they add up to 600, so that means each one of them has to be 300. So that's 300 times 60, and that's going to give us 162,000 centimeters squared. So far so good. Let's look at the area for each tile. Okay, the area for each tile is this. Okay, we have 30 by 30, so that means this is what, 30 squared. It's going to be 900 centimeters squared. Okay, so now we have the same unit. But one thing that we need to be a little bit careful is sometimes if the numbers are not very good, for example, if you only have a 50 by 50, right, and then you want to fit in a 30 by 30, right, you can, just use that divided by that, and then because we can't really get a very good number. So what we want to do now is we want to double check, does the 30 that we have over here divides all the side lengths on the diagram here, right? For example, 30, does that divide 600? Here, yes, it does. So we're fine. We won't have any left over. Does that divide the 300? Yes, it does. Same as this 300. Does that divide the 240? Yes, it does. Does that divide this part? What is this? This is actually also 300. Okay, so it divides everything. So that means, if you fit in anywhere. By the way, this is 60. So 30 also divides 60. So if you can divide anything, that means you were able to fit perfectly. All the little tiles. For example, this is one little one over here. So we got 30 by 30 over here. That means we won't have any left over. So all you need to do is use 162,000 divided by 900, and we're gonna get 180 pieces. And that's it for this question. Now the second question of the day, we're looking at this example exercise question. We want to cut 12 circles from a 30 by 40 sheet. We want to find the area of the leftover pastry. Okay, so in order to do that, we need to find out the radius for each circle. Yeah, they're all identical, but we need to find out the radius for each one so that we can use pi r squared. Right. Notice that we have 3 identical ones. So that means each one of them should have diameter 10. Each circle's area is pi r squared. My r is 5, so pi 5 squared. This is going to be 25 pi. Okay, since this is not our final answer, we're not going to round it yet. What we're going to do is we're going to use the big rectangle area subtracted by 25. But the 25 pi is only one circle. Okay, we have 12 of them. Right, this is only one of them. So what we're going to do is we're going to use the big rectangle area, which is 40 times 30, subtracted by 12 of those 25 pi. And if you punch everything into the calculator, you're going to get 257.5 centimeters squared. Okay, it's quite straightforward, this question. The last question of the day, we're going to look at a hard question. So this is definitely a level 7 to 8 question. We're going to prove that the orange area is exactly the same as the blue area. Okay, so first of all, let's find out the triangle's area. Okay, so the area of an isosceles triangle. By the way, this is actually an isosceles triangle, right? Because we have the side length being the same. The problem now is I'm not given any number at all. So what I'm going to do is I'm going to set an unknown over here, x. I'm not actually going to solve for the x, but I'm going to express my answer in terms of x, right? So for example, if you get your area over here, let's say, just random number. Let's say the answer is 4x squared, and then this one also turns out to be 4x squared. Then we can prove that they are exactly the same no matter what x value it is, right? We don't actually care about what x value it is, but we just need to make sure that both of them have the same expression in terms of x. That's exactly what we want to do. Okay, so knowing our goal, let's first of all express our triangle area in terms of x. It's quite easy because my base is x, my height is also x, and then I divide by 2. Okay, so base times height divided by 2, we got x squared over 2. So that's the area of this isosceles right triangle. Now the next thing we're going to do is we want to find out this area over here. So in order to find that area, we're going to use a quarter of a circle subtracted by the original orange area that we solved, right? The isosceles right triangle area. Okay, so that will give me the leftover. Okay, so what is the radius for this quarter circle? This is x, right? This is also x, and then this is also x. This is also x. So let's find out. the quarter of the circle is 1 over 4 times pi r squared, right? My r is x, so pi x squared, right? Subtracted by what I got before. This is x squared over 2. Okay, so I'm just going to leave it over there. So this is my answer. This is the area for this part over here. Okay, it's quite scary looking, but that's fine. We just leave it for now. Okay. Now the next thing that I'm going to do is finally I'm going to find out the area of this blue moon shape that I really want to find out. Right. In order for me to find out the area of that, I actually need a semicircle subtracted by this shape that I solved above. Right? And in order for me to find the semicircle area, I actually need to find out the radius. Right? So what is that radius? We need to look at the original right isosceles triangle. Right? So this is A, B, C. Right? This is the one that we saw before. We know the area. The area is x squared over 2. But we want to find out this length over here, which is half of AC. First of all, what is half of AC if this is x and this is x? Right? By Pythagoras' theorem, we know that AC squared is equal to x squared plus another x squared. Right? We have a squared plus b squared equals to c squared. But in this case, a and b are the same, so that's why we have x squared plus x squared. Okay? So in this case, your AC is actually equal to the square root of x squared plus x squared. That's the same as saying square root of 2x squared. Okay? So what is half of AC? What is this red part over here? Well, this is exactly just square root 2x squared divided by 2. Okay? Just whatever you have, and then divided by 2. Okay? So that's my radius. Okay? So here we go. Half of a circle, 1/2 pi r squared. What is my r? My r is this complicated guy. 2x squared divided by 2. Okay? Square root 2x squared divided by 2. And I need to subtract it by that area that I found above. So I'm just going to plug it in. Okay, let's keep going. So what is that going to give us? So we got 1 over 2 pi something squared. So let's square the whole thing. When you square the whole thing, the square root, we take out the hat. So we get to see 2x squared without a hat. But then on the bottom, you also square. Okay, 2 squared is going to give us 4. Right? Subtract. Let's break the bracket. So we have minus 4 pi x squared. On the other hand, this minus over here, because of this minus, we become plus. Okay, so plus x squared over 2. Okay, so what is that going to give us? Notice that we got the 2 and 2 cancel out over here. So this guy that you see over here, isn't that just exactly pi x squared over 4? And notice that the other guy is exactly also pi x squared over 4. Because we have 1 over 4 pi x squared. Like that. So that means what? That means we can cancel that out. Okay, so plus x squared over 2. Cancel, cancel. The answer is x squared over 2. And that's it for the area for your blue shape. And because the blue shape is exactly equal to the yellow shape or the orange shape that we saw at the very beginning, so you can just conclude that the area of the blue moon shape is exactly the same as the area of the isosceles triangle. And that's it for this question. So that's it for today. I'll see you guys in the next lesson. Peace.